Great webinar set up for you all today. We are talking about ultra high density Wi-Fi. I have special guest, Arjan Kievits with me today. I also have Eric Camille, our customer success officer, and of course myself, I'm Heather Dremel, digital marketing manager. So at this time, we are going to get on with the show. Arjan, I'm going to give you controls here.
Yep.
Ready.
So I'm going to talk about a case of ultra high density Wi-Fi specifically for the higher education, where I've done a couple of designs and installations together with colleagues of mine for performing digital exams in education completely wirelessly. And that's been a topic that we were requested for a couple of times now, and seems to be very popular and gaining in popularity. And I just want to take you through a couple of design challenges and the importance of the use case as a whole, which basically just goes through the typical design phase and gathering information phase that you are probably familiar with. And I want to share some results with you and talk you through the challenges that we faced and how important that design actually is, and even more important, the use case definition itself. Before getting into that, I was asked to do a little introduction of myself. I'm actually based in the Netherlands, so I'm talking to you from the southwest of Holland, near the coastline. I'm like 10-minute drive from the North Sea coastline. And what you see there in the bottom right is a picture of a oil rig that years ago I did a Wi-Fi installation for, together with a colleague. We did a point-to-point connection and a Wi-Fi connection in that oil rig, which was based just outside of my hometown here in the Netherlands, so that was cool. I'm a technical consultant for wireless for a company called Consia in the Netherlands. That used to be a company called Fosco. Probably most of you never heard of it, but we are a IT company, and I've worked for that company for over 25 years now. 23 years, more than 23 years of those 25, I've been doing wireless, and later it was called Wi-Fi. So I actually started doing Wi-Fi when it wasn't even called Wi-Fi. And I was very glad to be able to get a 1 megabit per second link up and running over 5 to 6 kilometers. So that's where I started out. I'm CWWNE number 325, which is kind of cool. Easy to remember as well. 3 plus 2 is 5, so that helps. And besides my work and interest in Wi-Fi, I'm also a really nature lover. I love to go hiking. I'm a amateur astro geek and astrophotographer. Do some drawing every now and then and build some wooden gadgets as well. So that's basically me. Not that interesting, but then you know who's talking to you. About Consia, like I said, we are an IT company, so we're an ICT value-added reseller, primarily for Cisco, but we also do Extreme and NetApp and some other stuff as well. And we deliver secure managed IT infrastructures in the Northern Europe area. So we are now part of a company that is based in the Netherlands and Germany, Denmark, Sweden, Finland, Sweden, Norway, and Slovenia, and consist of more than 950 people, which is just one big network of knowledge technical powerhouse, and that's who we are. So it's great to be part of. We started out as a little company in the Netherlands, and a couple of years ago we were adopted by Consia, so we are now one big happy family with a lot of technical knowledge on the networking side. So besides that, let's dive into the actual content of today's webinar, which is building a high-density WLAN for digital exams. I'm going to take you through the actual use case outline, how we got at least one of them. We've done several of them, but this is just one specific customer case where we started doing this kind of installation. And these are the prerequisites, or the the requirements that the customer gave us. And I was like, no, 2 sport halls, 7 meters high. That's cool. We got to deal with over 700 Chromebooks divided over those 2 halls, which is roughly 350 devices per sports hall. The standard access point used there was the Cisco AP2700, and we naturally started using external antennas, but I'll get to that a bit later. And the prime purpose and the only purpose for this was digital exams. So they wanted to take exams after a student take exams digitally. And actually, they didn't really have a requirement for the application. They didn't really know about it, but they had some other experience at another university and expected to have not that high of a bandwidth requirement. So the expectation was it would probably be very low, just a couple of click-through questions, and that's it, which is basically text-based. So we weren't that worried about bandwidth. Again, they had experience from another university where they had like 50 clients on a single AP, which worked fine. So more than confident that this would work over a single gigabit access switch with standard PoE. So these were the things that we had to deal with, and we were pretty confident that this would work. But I was kind of not sure about this. Well, the application will probably not require that much bandwidth, so we'll see. But don't worry too much about it. I was like, okay, I'm cool. Let's get on with it. And you'll see that my first worry will actually become reality in a moment. But let's go from here. So the design. We've got 2 large sports halls with high ceilings, and they are not only used for exams. They're actually sport halls, and there's a lot of things going on there besides doing an exam or 2 every now and then. You also are confronted with working with contractors that need to be very clear on what they have to do. So you need to be very clear on what you want them to do, which actually worked very well. They were very cooperative, so that's great. And this is not only true for this specific use case, but for all the others that we did as well. So we kind of gained a lot of experience there upfront and really was useful for other installations as well. But we also, at other customer sites, were confronted with existing Wi-Fi installations done by the customers themselves, which worked fine, as they told us. But this certainly doesn't guarantee a good performance when you go into the high density stuff, especially if you have a couple of hundred devices all accessing the network at the same time in a very cramped area. So know your Wi-Fi, know how RF works, and know that it works in certain ways. And this is actually something that we came across where we have a beautiful mesh around an access point with internal antennas just to shield the access point from rackets, balls, whatever you can throw at them. And of course, this will shield off the access point as a whole device, but it will also shield your RF. And for the occasional device connecting to the access point, it's okay. But if you do it this way, plus the fact that it's mounted against the wall, this is not going to help you in a high density environment. So this is not the way you should do it. Actually, really bad PHY solution in this case. But these are the things that we are confronted with every now and then. So it's also always good for a good laugh. Anyway, one of the customers presented us with a floor plan telling us, well, this is the setup that we are going to do. This is the layout that we're going to use with regards to the seating of all the different students. So that comes down to about 360 seats in the left side and around 350 on the right side, making it a total of a little over 700 clients. Well, okay, that's pretty dense, but we can work with that. So let's start at looking at the actual environment, which looks like this. So this is the ceiling that we have to work with. And what you will notice if you look closely is, and I don't know if my mouse will show you, there's these panels over here. So you can't really install something over there because this is the central heating system. There's lights, of course. There's there's these curtains that they can drop down, and these are very heavy and also shield quite a lot of RF. So we need to keep that in mind as well. Well, there's a lot of stuff going on in that ceiling that you have to take into consideration, plus the fact that eventually we turned out to just use these beams that are over here to install the access points and the antennas, which was the best place that we had to work with. So just to give you an idea, always take a look, and if possible, do a survey in the actual environment. So looking at the actual technical design, well, we verified the customer specification, because just sending out an email with what they want and not really talking to a customer isn't usually a good idea. So we really went into the discussion, and we were promised that those requirements are the actual requirements that they had to use to work with. So okay, we're good at there. So it's verified all the requirements. Then we came down to, well, we really would like to survey this area because this is not your average installation. Well, so they said, that's fine. You got 1.5 hours if you come real early, because this is a sports hall in a university. It's booked solid. So either be early or be gone. And we ended up getting about 1.5 hours to do the site survey. And we really want to know what those antennas that we are intending to use were going to do for us. So we took it upon us to start early and get that data recorded. But then we had to do the rest of the design mostly predictively. And we used Ekahau for that, of course. Who doesn't? So that helped a lot. And we came down to a design with 8 access points per hall, which gave us about 40 to 45 clients per AP or radio actually in the left hall, and about 43 clients per AP radio in the right hall. We only went for 5 gigahertz, and we only used 20 megahertz channels, specifically because this is a large open area. And even though we used the 2566 directional antenna, for which you can see the propagation scheme over there, so that's the actual antenna signal plan, or what you call it in the English, but you know what I mean. So that's highly directional, but even so, we saw the signals bouncing around and ending up at almost the other side of such a large sports hall, although it's very directional. So going for anything other than 20 megahertz is, first of all, creating far too many overlap in channels. You don't have that many channels, especially not in Europe, that you can use. If you're going to 40 or 80 megahertz, yeah, your bandwidth will increase dramatically, but your channel overlap will be too much. So in these kind of high density with relatively low bandwidth requirements, or even the simply higher bandwidth requirements, anything above 20 megahertz is going to bite you real bad. So we ended up with a 2702 access point external antennas and the one that's shown here. But again, this is a sports hall and a university, and I don't know about you guys, but if you went to college and you were a student over there, you would do pretty much any challenge for a case of beer. So we had to shield off those access points, just as they did for the clocks that are over there. The big difference is, compared to the picture that I've shown you before, we are shielding the AP and not the antenna. So we ended up with this installation, a perfectly shielded access point that shields the antenna connectors from any hard object being kicked against it, struck by it, or whatever we did. And we actually did some tests on those antennas to see how much they could withstand. It's actually pretty rugged. So we ended up installing them like this, and worked together with the contractor to come up with a drawing that they know exactly which connector goes onto which antenna, and they used a high rise. And again, like I said, we need to work together with those contractors because they get about the same time to go into that room, or in the middle of the night have to install them, and it has to be right directly. There's no room for error whatsoever. You can't go back with a high rise and just change them anytime you like. That requires some planning. So we ended up with a theoretical prediction from Eckhout that looked like this. We did a channel planning in there. We turned off the 2.4 gigahertz because we only used 5 gigahertz. And we tried to do this as much as possible. So what you see here is 8 access points with 8 channels. And we ended up with a very clean channel plan. So next comes testing, because we've now got all installed. We did the configuration, turned off the really low bandwidth, did everything from 12 megabits per second and up, and even 24 as a first mandatory data rate. And then, even though the initial requirement said that we only were going to do basic text-based exams, the customer decided to start testing with video. And they actually came up with a solution where the exams would have video content in them instead of just text-based. Well, that's a surprise. And besides that, we're not going to use 350 Chromebooks. No, we're going to use 500 of them because we kind of saw the possibilities, so we added a few more. Plus the fact that we're going to space them a bit closer together than we originally planned. So the density suddenly became a lot higher. Well, as you may or may not know, if you're going to start using video, then you're confronted with bandwidth requirements ranging from 1500 megabits up to kilobits up to 6000 kilobits per second, depending on the resolution you're going to use and the way it's going to be utilized, either to YouTube with progressive thinning or not. At 500 clients, the network pretty much died on us. This is a lot more than we anticipated on. So we're over 60 clients per radio and per AP, and channel utilization simply maxed out at 90%, which basically means your Wi-Fi network is dead. When we lower the clients at 250, so that's about half, but again with video, it kind of works. But what you noticed is, first of all, you see in this picture that all the devices, all the Chromebooks are at ground level. That's okay. It's a lot of Chromebooks. But what you also see, which is the most interesting part, is that diagram at the bottom, which is the bandwidth measurement done at the aggregate switch level. And you see this up and down diagram, which basically means that you get a burst of data from all the clients, and then it maxed out at 90%, dies on you. Clients start to stabilize again, trying to retransmit or receive, request new data. And again, you get this spike and then it dies on you again. So this is a typical way of seeing that your network is dying on you due to a high utilization rate. So back to the use case. Again, my gut feeling in the early stages already said that that bandwidth requirement just doesn't feel right. And eventually we ended up with the reality of the use case, which is not only 2 sports halls, but additional classrooms that they want to have fitted with this solution, over 1,000 Chromebooks instead of 500 in each or 700. Which added up to over 40% more clients than anticipated and designed for. We ended up with a different AP model, which we'll show you in a moment. And again, the application now suddenly became video content based, if possible at 1080p quality, plus an Amazon virtual environment in which the exams now were being placed. So that's quite different from the original requirements. They eventually came up with the fact that they had no idea what kind of application or access point was used at the other university that they first contacted. So yeah, the only thing they knew was they had really good experience with those Chromebooks, so let's use those. Okay, this was my initial reaction when I saw that, but you have to work with the customer, and we want to go for the best solution. So let's work with that information and see what we came up with. And that is, we went back to the drawing board. We did a preliminary test in a separate classroom and used a 2800 from Cisco with dual 5 gigahertz enabled. We also tried this with a 2700, but we came to the conclusion that the chipset and the memory on that access point simply wasn't enough to host that many clients with a reasonable bandwidth and the requirements that they had. So the 2800 with the same antenna could reach up to 71 clients and even more if you wanted to on a single radio at 720p video resolution. So our limit of 40 to 45 clients per radio was not that strange to think of at the first time. Actually, it works fine at 50 and even 60 or 70 clients, but we want to have some margin here. So our new design was based on 10 access points using dual 5 gigahertz, which means that we basically have 20 channels, 20 separate radios to our for us to use. Again, with the same antenna, but we had to use a static channel plan with 5 gigahertz, 20 megahertz channels only. We did not want the system to figure out the channels themselves, because you would end up with multiple equal channels because they were distanced too far apart to let the algorithm select the right channel at the right time. So we did a static channel plan, and we reduced the power level to a level where we could at least take in consideration the body absorption of all those different students that would be together in one single room at the time. So if you start measuring this, you get a really high channel signal strength. But once you get 500 bodies in there, and this sounds a bit gruesome, but they were still alive when they got there. So getting those bodies in there really absorbs a lot of RF energy. So you need to take that into consideration. So we ended up with this design. Still 10 APs in this case, dual antennas, dual 5 gigahertz, mounted at the ceiling. And this is what it looks like when you start testing. So you can see the access point still being mounted here at the side of those beams. And we had the antennas still at the bottom of those beams. So there's one over here, there's one over here, and on the other side as well. Taking into consideration those shields, those curtains that they can drop, we actually put them on tables all together. And what you can see here on the left image is all these screens turning green, showing a couple of divers. It's not that really clear to see, but this is actually video content, and they used a application by which we could start all clients at the same time, which basically means that we started testing with video again for 501 Chromebooks in one single hall, and they had this app where we could start all the Chromebooks at once. So they rebooted at once, which means that load balancing kicks in the Wi-Fi environment, separate or distributing the clients as evenly as possible. And within 1 minute, all clients were booted, connected to the Wi-Fi network, stabilizing and running video, which is pretty impressive if you see it happening. We had an average throughput of about 2.5 megabits per client, and our requirement calculation came down to we need a 2.3 megabits per second throughput if we want to have a smooth experience for the students taking an exam. That means that we came with an absolute throughput per access point of about 370 megabits per second, and an average channel utilization of 60%, which is not that bad. I mean, anything above 70 to 80% pretty much dies out your network, but 60% is pretty good. And we actually ended with a virtual environment test for 250 clients, which was kind of a bit of an overload for AWS, because we pretty much killed the Amazon environment at the moment when we started these kind of application with this bandwidth. Now, to give you an idea of how this looks, you see the bottom graph now compared to the other graph that I shown you earlier, where there's really this really smooth bandwidth all over. Again, this is measured from the switch where all the access points were connected to. So there's no retransmission, no backing off by clients, no big utilization crash or whatever. This looks really, really good. And when you start looking at the video that I took from that, you can actually see on a single client excluded, almost all 501 clients running this video simultaneously. And I hope this comes through pretty good. There's this one red screen over here, but this is still starting up. All the others are running that video simultaneously over that Wi-Fi network. So this was the grand test that gave us the confirmation that exams would go fine by now. There's one other client in the back. You see it in the very last frame that's turned red as well. Again, these were two clients that just didn't want to go online for some reason. All the others, so that's 499 devices running video at the same time within 1 minute of rebooting them all. So that's how we did this. This word got out really quickly, and other universities really want this as well. So we've been doing these kind of installations since then at a couple of other universities as well. So there you go. That's how we did it.
Awesome. Good stuff. All right, so now it's time for a little Q&A session. So if you have any questions, please drop them in to the Q&A panel here. First, we do have a comment. It's from Nick, and I'm sure you can relate to it. He says, I can still relate to the customer massively changing their requirements after the first design is made. I think we've all been there.
Yeah. And then you think I've got it all covered. I've talked to the customer. We all came to the same conclusion. Yeah, these are the requirements, and then suddenly it's changed. And that's not that uncommon. I mean, requirements do change, but they have a profound impact, and that's what I wanted to show. Especially if you look at these kind of use cases. Normally, you might be able to take some changes and deal with them without making any massive design changes. But in this case, 40% more clients and video and all that stuff was a bit too much.
Right. All right, and we've got two questions from Chris Kelly. The first one is, was there any consideration for SLAs for needed minimum client throughput?
Well, the only SLA was about this application that they expected to have a couple of kilobits per second. It was just text-based yes or no questions that they would start to use. So the requirements for video, actually, we worked together with the customer to see what this video would be. And still, they really didn't have a real idea because the exams are put together by professors and teachers that really don't know upfront what they would put into these exams. So we had to make like a wild guess that, anything around 720p quality video will probably be good enough. And let's calculate from that what the bandwidth requirements probably will be. So that's how we did the bandwidth requirements.
All right, and the second question we got from Chris is video done using broadcast or broadcast to unicast conversion on the APs?
Now this is, luckily it is hosted on a YouTube kind of platform. So it is unicast. Luckily, in a sense that it's predictable, more or less, or at least it's got a lot of buffering mechanisms in there, which is kind of good because that kind of distributes the load a bit more evenly. If it would be multicast, then everybody would get the same multicast stream at the same time. And honestly, not everybody is as quick with their answering questions. So the time that the video is shown depends on whether you are where you are in your exam. So it couldn't be multicast. Therefore, if it was multicast, then naturally we would have converted it into unicast when it came to the AP. But in this case, it's a different time where that video needs to be delivered to every student.
Mm-hmm. All right, we've got one from Raymundo, and he asked, so these APs are not controller based. Since a manual channel design was used, what channel range was used?
It is controller based, but we didn't let the controller design or select the channels. So we used, I need to be correct on there, 16 channels. No, actually it was 8 channels to be correct. And we divided them as much as possible to minimize the channel overlap. So similar channels were spaced out as far as possible. So we, even though the controller does channel allocation automatically for the rest of the campus, for this specific area, we did a manual override.
Gotcha. I got a question from Nick. It's kind of a two-parter. So what type of antenna was used, directional or sector antenna, and how about antenna gain?
The antenna used was the Cisco 2566, which means that both 2.4 and 5 gigahertz have a 6 dBi gain, but we didn't use 2.4 gigahertz at all in this area. Actually, we only used one SSID, did a 24 megabits data rate as first mandatory rate, power level 3, so it was really down to minimizing any overhead. And trying to get as much signal directed downwards. So we use the directional version of this antenna, which is 6 dBe, 6 dB together with power level 3, which is well below 100 milliwatts. But we need to take into consideration all these bodies that would end up filling that room. So it's kind of actually, it worked really, really well. And we did a test with well, actually, the real test was a real exam. So fingers crossed, and it went really well. But you have to be static in these kind of environments, because if you let the controller decide what to do, as soon as this sports hall empties out with all those people, it starts readjusting everything, and you'll need about at least 20 minutes to half an hour for it to stabilize. And by that time, everybody's frustrated and it doesn't work. And you get really strange load balancing of clients. So not a good idea. And in fact, the reason that you not want to do this statically and have all the laptops connect to the Wi-Fi as fast as possible, together as possible, is that the load balancing algorithm only kicks in when a client connects to an access point. And since they don't have that many access points to choose from because of the directionality of those antennas, you have to have them balanced right at the beginning.
Right. All right, we'll take just a couple more. There's a lot coming in here, so sorry if we don't get to Olivier asks, I'll try to make this kind of a two-parter. So how long ago was the project, and would you do anything differently if the project came up today, kind of slash any other foreseen issues that you haven't mentioned?
The project probably was turned over in a couple of weeks because we were really right on top of it. Because we did this, if I recall correctly, in the summertime, and pretty soon after that, exams started to be taken. So we had to really work on it. And anything else that what we did notice, and what I didn't really mention in this webinar, is we did come across with some strange behavior when it comes to the load balancing of clients. So it wasn't evenly spaced out. So you could see an access point with one radio having like 20 clients and the other one 45 or something. But since it all worked, we didn't focus on getting it as equal as possible, because it turned out to be too difficult to even try and reach that. Clients still have their own algorithm of connecting to an access point. So trying to manipulate that as best as possible. Basically, we just said, well, if it works okay, then we are not going to be bothered by the fact that one radio has 25 clients and the other one has 35. I mean, it's all fine, even if it's spaced out even, as long as it works okay. And we saw that in the preliminary tests where we could go up to and over 70 clients per radio, and it would still work fine. So we had more than enough margin. Would I do anything differently? Well, now with this experience, knowing that the content of exams isn't always as straightforward as we thought it would be, yeah, that's something that I will drop on the table from the first moment on.
Great. And Don Cook is making a celebrity appearance.
I'm not alone.
And Tim Vada. And lots of our team. Hi, everyone.
Sorry to miss it today.
They'll be back next time. Cool. Let's take one more question while we've got our friends here. So let's take it from Ralph. Did you use DFS channels?
Yeah, we had to. Here in Europe, and I'm not really sure how it is in US, but here in Europe, only the first 4 channels are non-DFS. If you want to have enough channels anyway. So the second 4 channels are DFS already. So yeah, there was no doubt about it. And plus the fact that we only have, only quote unquote, 17 channels in the Netherlands. So we couldn't use the very, very high channels as opposed to what you can use in the US. You have like 23, I believe. We don't have that luxury. You can see the same thing happening with 6 gigahertz now. You guys get 1200 megahertz. We got 480. Damn.
Awesome. All right. Well,
lucky you guys.
Choose your own adventure, everyone. All right. Well, sorry if we didn't get to your question. A lot of them ended up coming through, but feel free to reach out to Arjan. I'm sure he's happy to answer any questions after the fact. But wonderful webinar, Arjan. Thank you so much for taking the time to discuss today.